In this video, we will solve a question on growth accounting. The question is, let the production function be given by yt is equal to at times kt raised power alpha times ht raised power beta times lt raised power 1 minus alpha minus beta, where at a time t, yt denotes the output, this at denotes the level of total factor productivity, kt is the physical capital, ht is the human capital, and lt denotes the labor. The value of alpha is 1 upon 5 and the value of beta is 2 upon 5. If the growth rate of that is output, physical capital, human capital, and labor are being given as a respectively 10%, 5%, 5%, and 10%, we have to find out the growth rate of the AT, that is the growth rate of total factor productivity. Okay, so let's write the equation that is being given us here. What we are being given? We are being given YT, that is the Y denotes the output at a time period T is equal to AT times KT raised power alpha times HT raised power beta times LT raised power 1 minus alpha minus beta. Okay, also we are being given here, that is the value of alpha is 1 upon 5, the value of beta is being given as 2 upon 5. Also we are being given here the growth rate of, let's denote it by G subscript Y, the growth rate of output is being given as 10%, the growth rate of G subscript K, that is the growth rate of physical capital is 5%, the growth rate of HT, that is human capital, is being given as so we have 1, 2, and 3. It is also 5%, and also we are being given the growth rate of labor. Let's denote it by G subscript L, that is being given as 10%. We are supposed to find out the growth rate of A, that is the growth rate of total factor productivity. Okay, given these variables, let us try to solve this question. So given this production function, let us take log on both sides. That means log of yt will be equal to log of this whole stuff, that is at times kt raised power alpha times ht raised power beta times lt raised power 1 minus alpha minus beta. Okay, and let me be very specific here. Okay, so we know from the law of logarithm, if we have log of a b, it is equal to log of a plus log of b. Okay, and also we know that if we have log of a raised power n, okay, we write it in this fashion, n log a. Okay, using these very formulas here, what will happen? So log of yt will be equal to, so we have first log of at plus log of kt raised power alpha plus log of ht raised power beta plus log of lt raised power 1 minus, let us take minus common here, we are left with alpha plus beta. Okay, using this very formula, then we can rewrite it as log of yt is equal to log of at plus, here alpha becomes coefficient, so we have a times log of kt, using the second notation here, second formula, plus here b becomes the coefficient, we have log of ht plus here this 1 minus alpha plus beta becomes coefficient, we have then log of lt. Okay, let us take differentials on both sides. Okay, differentiating both sides with respect to t. So we have the derivative of log yt will be equal to 1 upon yt times del yt. Okay, similarly log of at will be equal to 1 upon at times del at. Okay, plus a the derivative of log kt will be 1 upon kt times del kt. Okay, from the derivative of log of n is equal to 1 upon n. Okay, similarly we have plus beta here, log. Okay, so in the next equation we have beta, the derivative of log ht will be 1 upon ht times del ht. Plus here we have 1 minus alpha plus beta. Derivative of lt will be 1 upon lt times del lt. Okay, so let us rewrite it here. Let me see if I have the space here. I don't have the space, so let's write it here. So I write it in this fashion: del yt upon yt is equal to, similarly here I can write del at upon at plus we have here alpha. The value of alpha is being given us as 1 upon 5, so let's write 1 upon 5 in place of, so I can write here del kt upon kt plus the value of beta is 2 upon 5. Let's write it here 2 upon 5. Then we have del ht upon ht. Okay, so del ht upon ht plus then we have 1 minus alpha plus beta, and let us see what is 1 minus alpha plus beta. So we have 1 minus alpha plus beta, so alpha is 1 upon 5, beta is 2 upon 5, which implies it will become 1 minus, bases are same, we can, sorry, denominator is same, we can add up the numerator. It becomes 2 plus 1 is 3 upon 5. This is equal to, it becomes 2 upon 5. Okay, so this whole 1 minus alpha plus beta sums up to 2 upon 5. So let's write it here 2 upon 5 times del lt upon lt. Okay, now what is del yt upon yt? It shows, this shows the change in the output divided by original output. Okay, what is the change in output divided by initial output? It denotes the growth rate of y, that means the growth rate of output. Similarly, the change in technology, total factor productivity upon the original. Simple thing, when some function changes and when we divide it by the original function, we get the growth rate. Okay, so del at upon at denotes the growth rate of total factor productivity plus 1 upon 5. Del kt upon kt denotes the growth rate of physical capital plus 2 upon 5. Del ht upon ht denotes the growth rate of human capital plus 2 upon 5. Del lt upon lt denotes the growth rate of labor here. Okay, let's denote it by G subscript L. Now we know from the question that growth rate of output is being given us as 10%, so I can write here 10% is equal to growth rate of, and let's write it here, growth rate of total factor productivity that we are supposed to find out. Let's write it as it is, plus 1 upon 5. What is the growth rate of capital? That is 5%. Okay, let's write here 5% plus 2 upon 5. The growth rate of human capital is also 5%. Let's write it here 5%, and plus 2 upon 5. The growth rate of labor is 10%. Let's write it here 10%, which implies 10% will be equal to growth rate of total factor productivity plus, so 5 gets cancelled, we are left with 1% here, plus here 5 gets cancelled, or it becomes 5 2s are 10% upon 5% is 2%. Okay, that makes more sense. Plus here 10 2s are 20 upon 4, which, sorry, 20 upon 5, which comes out to be 4% here, and let's write it here 4%. We need to find out the value of total factor productivity. So 10% is equal to GA. So this is this is 7%, which implies growth rate of total factor productivity will be equal to, transposing this 7%, it will get subtracted, it becomes minus 7%. That means growth rate of productivity will be equal to 3%. Okay, so I hope I make myself clear in this video. By total factor productivity, what we mean the Solow residual, the change or the increase in the growth rate that is not explained by these terms, that is by the physical capital, human capital or labor, and which is only explained by this, the state of technology, what we call the total factor productivity, and at times we call it Solow residual. Okay, I hope I make myself clear in this video. Thank you.